All right, so how about some external morphological differences between amphibians and reptiles? Now that sounds intimidating, maybe, but what is on the outside of reptiles that you would be able to distinguish them from amphibians? They've got scales, reptiles do. What else? What's quads? Oh, claws, that's right. Okay. Reptiles got teeth, and like you said, they got claws. Their skin is scaly. So then, how's that different from the amphibians? So what do you observe on the outside of amphibians? Okay, they got moist skin, toe pads instead of claws, and no teeth. Okay, because oddly enough, when you look at, sometimes I feel like a reptile putting lotion on our hands because it's so dry and scaly, especially in between the knuckles. It gets really dry in there, and then it cracks and breaks and hurts. And okay, so what about the inside now with reptiles? We spent a little bit of time on that with circulation last week. So the inside of amphibians compared to reptiles. No, it's pressurized, so it's closed. No, it's closed, it's pressurized. So the open circulatory systems were last semester with invertebrates. It's when, well, you have to predate that of, well, they do have an efficient circulatory system, but yes, the mollusk is open, arthropods is open, so in that case, that's what we're looking for. But why is it more efficient in reptiles? What about the pressure? Yeah, their blood pressure is higher, and typically we think the term high blood pressure is a negative effect. Well, yes, it can be in humans. That's certainly true. But if the blood pressure is higher, means it can be more efficient in sending these nutrients and oxygen to where they are needed. But there's something significant about their pumping mechanism in reptiles. Okay, it's not only just the number of chambers, but there's something significant about certain reptiles between those ventricles. Right, which is catastrophic for mammals, birds, and humans, having a incomplete separation between the two chambers. Because if that is the case, what's going to happen in those ventricles? Why is it awful for us? That has to be corrected surgically. Yeah, because you'd possibly be sending deoxygenated blood to not just the rest of the body, but also to the brain. That certainly needs those vital nutrients. Okay, so now we move on to respiration. We're a little bit ahead of time, which is fine, because the two biggest chapters are left, which you would think, because as we've progressed through this curriculum, okay, we started with natural selection, then we started talking about the simplest animals, which were who? Say that again? Sponges. Then the first type of movement took place between phylum Porifera to cnidarians or jellyfish and anthozoans and those assorted animals. Then who came after the cnidarians? We've mentioned them. Mollusks. Okay, those are animals that have a shell and a radula in their mouth. And then who came after the mollusks? The arthropods. And then in every step that we've taken, what's happened with the complexity of the animals? So they become simpler or more complex? A lot more complex, because now we're no longer talking about invertebrates, those animals that lack a backbone. Once we start talking about fish, those are, of course, what we call vertebrates, which means there is a vertebral column that protects a spinal cord. Now, the metabolism might not be very high yet. That is true, but the complexity of these animals is certainly, again, higher. But when it comes to that of reptiles, is it more or less, let's say, efficient than amphibians? It's more efficient, okay? And one of the reasons for that is, how do amphibians get oxygen? Not just by lungs, but what other aspect? It was in their skin, we said. Nope, they don't have gills. They may start their life as aquatic larvae to where they have gills. That part's true. But once they become terrestrial, then those gill functions are going to be lost and have to change to what? If you breathe on land, what is your breathing mechanism? Well, that's what it goes through. Yeah, lungs, okay? So in this case, this is approximately where we had left off, okay? They have the higher blood pressure in the amphibians, okay? 2 atria, 2 ventricles. We talked about this, an incomplete separation, but because of that higher blood pressure, that is just not going to mix between the 2 chambers. Now, how is it possible that it happens here but not with that of humans? That I don't have an answer for. Maybe it's the size of the incomplete separation, but again, you have to look at the metabolism. What is this metabolic activity? How is that different from us as humans or even mammals? This is a lot slower. So that's possibly why they can get by with something like that. They don't always have to have that large amount of oxygen sent throughout the body. Yeah, it has to be sent to the brain, but it's getting at least some of that oxygen, but maybe not nearly as much. So respiration is better developed than those of the amphibians. Okay? So here it's lungs from the time they're born. As aquatic larvae, okay, amphibians might have gills, but then they lose that function and it turns into turns into lungs. Does anyone know where this structure is in a human? A pharynx. Anybody possibly know? Okay. So one way you can do a process of elimination, okay, would this be in humans? Would it be above the hips or below? Okay, so we can go higher than the pelvic cavity. Okay, then can we go into the rib cage? Okay, so can we go higher than the rib cage? It's in your throat. That's where your pharynx is located. But the pharynx would approximately be about right here, because you have to be able to swallow. And then what related structure might be just a little bit lower that is pronounced similar to pharynx? Your larynx. And what is your larynx? Does anybody know? No one's suffering from laryngitis. Because if you have laryngitis, that means, yeah, it can be strep throat, but you have inflammation here in your in your throat, a little lower than your throat, okay? So, I mean, that's a little tricky because you do have tonsils back there that can become inflamed should you still have them. I've got my tonsils yet. Both of my brothers had theirs removed. Sometimes there's different types of trends that take place with surgical procedures. When they were growing up, it was just common practice. If you have a problem with tonsils, get them out of there. And then by the time I had reached that age, I think it was believed that, no, leave them in. So sometimes that can vary whether certain doctors say take them out or leave them in. But anyway, these pharyngeal membranes are in the back of their throat of these animals. So not only do these aquatic turtles, are they found on the land, but they can spend large amounts of time underwater because this is not a true gill, but these membranes then can actually extract oxygen from water. So it's not that they can spend all their lives under the water, but they can spend some for a certain amount of time. And parts of that would be probably for navigation purposes, or it doesn't help them navigate, but would allow them to stay underwater to actually move from one part of the ocean to the other. I think a person might be surprised on how many underwater currents are actually taking place. Whether it's due to the tide, there's rip tides, there's different types of, I think they're called gyres, and I think it's the Eastern Atlantic Current is another one of those that they may use for navigating throughout the ocean. It's just a different way of propelling them along through the water. Okay. So we had said this about being a terrestrial animal and being found on land. These animals have a greater density in their bones. So if that's the case, can they handle more stress? If it's more dense? Yes, they can handle a lot more stress. Now, one of the things that we see, legs are splayed outward, and it should say like so belly is close to ground. They can do that, but if it's splayed outwards, that means they can also lift their bellies back up again. And one way to possibly make sense of that, okay, it's really difficult for giraffes to drink water from a watering hole because they just cannot get their get their head down to drink water. Okay? So for instance, if we ourselves want to touch the ground, I mean, once you get older, it's a little more tougher. Okay? I can't touch the ground like this. I'm just not flexible. I'm getting older, but that's because my legs are closer together. But what can you do to bring yourself closer to the ground? Do what? Well, we're doing that. Yeah, so if you spread your legs out like this, now it's a lot easier. So giraffes would do the same thing. They would splay their legs out. Now their head can get closer to the water. So what we see here, okay, if they don't want to carry a lot of weight with them, they'll just splay their legs out and let their belly sit on the ground. I mean, amphibians do that constantly because their limbs are further out to the side. Reptiles, on the other hand, their limbs are maybe closer to right angles. So they can splay their legs out and then just let their belly rest on the ground, or they can pull them in when they're not splayed and then do their assorted types of movements. Okay, where does that get us to the lizards? Close. Okay. So we'll talk about this nervous system and then we'll stop at the end of this. Okay. Okay, so these different types of behaviors, it could be in reproduction, it can be in food gathering, and with that, when we're talking about food gathering, okay, only the large might survive. So what I mean by that is when we go all the way back to August, okay, and this is where we use one of these examples. Do we remember those 5 observations that Darwin made?
Oh my God. Oh.
That was perhaps number 3, okay? Which reminds me, how with your hand, we know you can count to 5, but how do you use your hand to count to 5? Is what comes first, the thumb or the index finger? You go 1, 2. See, you use your thumb first. Why is that? You use your index finger. 1, 2. Then I can't do that. Then 4, then 5. But you start with your thumb and go 1, 2, 3.
Yeah. Well, I guess it's easier because then when it comes to 3, you're not going across. Because then you can just do the side like whichever for 3.
Okay. Asked and answered, I guess. But anyway, the first observation, something about gametes. Okay? There's an extremely large amount of gametes that are produced.
Yes.
Okay? And with that, anytime gametes can be placed together, that means a potential offspring can be born. Okay? So what we're saying here is maybe every, let's say, clutch size with all these gametes might result in a clutch size of, we'll say, I think we use a number of 50 alligators or crocodiles at a time. So every female alligator is laying 50 eggs because of all these gametes. But one of the things that we see, what's true about them embryos as they develop? Are they going to survive to adulthood? No. No, that is definitely not going to take place because natural populations can fluctuate in size. That was the second one. Then your survival of the fittest. Oh, excuse me. Thank you. And then the food and habitat was number 3. And then number 4, no 2 individuals look alike. Then what was the 5th? Yes, offspring tend to resemble their parents. Okay? But in this case, so some of this advanced behavior, not only is it survival of the fittest, but maybe they feed upon one another. So that is possibly why not all crocodiles survive to reproduce, or alligators, because they prey upon their own kind. Cannibalism is fairly common, whether it's that of reptiles, spiders might do that. This type of behavior is really unknown to amphibians. So it can be reproduction, it can be food gathering. So the nervous system is by far, it's a little more advanced in reptiles than it is in amphibians. Okay, so tomorrow, looks to me like we'll start talking about the Jacobson's organ. And that's found in both lizards and snakes. It's just a special type of apparatus that helps snakes determine scents. You could say, yes, they do have nostrils, lizards and snakes. They've got nostrils, but those are not what you think that they're actually used for, because for us, nostrils is not only just for respiration, but also what? For smelling. For nostrils in reptiles, yes, it's used in respiration, but it's not used for determining scents. That's what their tongue is for. That's, of course, why you see the characteristic sticking the tongue out, flicking it, bringing it back in. Okay, so we will begin with that tomorrow. Catch up to you next time.